Hi guys, this is chapter 6-4. It's all about graphs of the sine and the cosine functions. I'm going to start off by saying we're going to do an xy chart right here for the parent function, y equals sine. If I plug in 0, y equals sine of 0. Well, when I plug in that 0 for x, what do I get for an answer? Well, I go over to my unit circle. Sine of 0 is, if you remember it's the y coordinate, it's 0. So when I plug in 0 for x, I get an answer of 0 for y. Okay, I'm going to jump down to pi over 2. Y is equal to the sine of pi over 2. So I'm up here, my y coordinate is 1, so when I plug in pi over 2, I get an answer of 1. Jumping down to pi, y is equal to the sine of pi. I'm over here. I am, when I plug in 0 pi for x, I get 0 for an answer, okay? Y is equal to the sine of 3 pi over 2. I plug in 3 pi over 2. When I plug that in, I'm down here. I get my sine is negative 1. Okay, and then lastly, if I plug in the 2 pi, I would get sine of 2 pi. 2 pi is over here, back over here at the start. So again, my y coordinate is 0. Okay, so I'm not doing all of it, but here we go. Look, check it out. It's the whole thing. So let's just kind of plot some of this. Okay, actually, we can plot all of it. What the heck? Why not? All right, first point is 0, 0. When I plug in pi over 6, I get 1/2. So here's what I'm going to do. Ooh, I hate this graph. Okay, let's do this. I'm going to make this white. I'm going to use white and white out this whole thing. I don't like it. It's yucky. Okay, sorry. Okay, that's better. Let's do this graph. Okay, when I plug in, when I plug in 0, I get 0. When I plug in pi over 6, now watch, I'm going to make this pi over 6 right here. I'm going to go in increments of 1/6 pi. I get 1/2. So here's 1/2. I go right there. My next point is pi over 2, 1. So think about it. 1/6 pi, 2/6 pi. This is 3/6 pi, so this is pi over 2. And I'm up here at 1. Okay? Next point is 5 pi over 6. So this is 3 pi over 6, 4 pi over 6. This is 5 pi over 6. And that's 1/2 again. Next one, so this is 6 pi over 6. So this is pi. And I'm at 0. Next is 7 pi over 6. So I'm right here. And that's negative 1/2, so we're down here. And next point is 3 pi over 6, so 7 pi over 6, 8 pi over 6, 9 pi over 6 is right here. Why am I writing that? I should be writing 3 pi over 2, right? Yeah. All right, so now I'm at negative 1, I'm down here. And then my next point is 11 pi over 6, so that's 9 pi over 6, 10 pi over 6, 11 pi over 6. And that's back up to negative 1/2. And then lastly, it is 2 pi, which is right here, 0. All right, so watch, check it out. We kind of make this curvy graph. There we go. There's my sine graph. That's the parent function. That represents one period. Okay, remember what period is? Once you go through one period, you just repeat that whole graph run. It bothers me they don't put arrows. Blech. Okay, the domain of this graph is negative infinity to infinity. The range goes as low as negative 1 and as high as positive 1. Okay, if you remember what even or odd means, an even function is symmetric to the y-axis, which this clearly is not. An odd function is symmetric to the origin, which this function clearly is. So this is an odd function, okay? We just said the period is from 0 to 2 pi. Look, 0 to 2 pi, and then it repeats itself. And then the rest of this stuff is all right here, okay? So like here's the x-intercepts, etc., etc. I don't want to do that. I want to talk about this really quickly. If I want to transform the sine function, here, like this, think of this. This is just a parabola, right? Parent function. That 2, if you remember, you multiply all your y coordinates by 2. So if I transformed it, it would be 0, 0. Now it would be 1, 2, and 2, 8. 4, 5, 6, 7, 8. So then I reflect those points. You remember all this. You guys are good pre-calc students. All right. How do you think that's going to have an effect on this lovely graph? If I have a 3 here, well, you guessed it. I'm going to multiply all my y coordinates of the parent function by 3. So here we go. We got 0, 0, because that y coordinate doesn't change. Pi over 2 comma 1. Well, now it's going to be pi over 2 comma 3. Okay, next point is pi 0, so it's still pi 0. 3 pi over 2 negative 1. It's going to be 3 pi over 2 negative 3. 2 pi 0. Okay, so look what this did to my graph. It just made it kind of go higher and lower. So think of the domain. The domain does not change. It's still the same. Did the period change? Nope. So the period is going to be 2 pi. Okay, but the range has changed. So this is going to have an effect on the range because now I'm going as low as negative 3 and as high as positive 3. Okay, see this number in front of the x? Inside of a parenthesis, we're going to call that omega. We're going to talk about that in a second. That number 3 that is in front, we're going to call the amplitude. Okay, so in that one we just did y equals 3 sine x. That means that the amplitude is equal to the absolute value of 3, which is 3. But I want to make a point here. If I had this as my function, okay, my amplitude would still equal 3 because it's the absolute value of negative 3, which is 3. However, the graph would change because now it would be reflected over the x-axis. Right? Okay, we already talked about that. Let's talk about this. If we have a 2 in front of our x squared function, we're back to just graphing the old parabola. You remember what we do, right? You multiply your x coordinate by the reciprocal of 2, which is 1/2. So if I did that, this would be 0, 0. This would be 1, 1/2. And this would be 2, 2. And then I could reflect it and boom, check it out. That's a compression. Okay, so we're going to put this all together here. I have an amplitude, I have an omega, and look, my amplitude's not going to change. However, look, that minus sign right there. I'm going to take, this is what we're going to do here for this function. We're going to take all the y's, so you're going to multiply all the y coordinates by negative 1. You're going to multiply all the x's by the reciprocal of 2, which is 1/2. Okay, so here we go. You ready? 0, 0. That doesn't change when you multiply. This one right here, pi over 2 times 1/2 is now pi over 4. And when I multiply 1 by negative 1, it's going to be negative 1. So I have 1 pi over 4, which is like halfway here, negative 1. There's that first point. Next point. What's the second point? Okay, pi 0. So now it's going to be pi over 2, 0, right? So pi over 2, 0. Next point, 3 pi over 2. I'm going to multiply that by 1/2, and that is going to be 3 pi over 4. And I'm multiplying negative 1 by negative 1, which I get 1, positive 1. Okay, over here, 2 pi 0. I multiply 2 pi by 1/2. I get pi 0. Check it out. Here's a couple things that have been happening here. First of all, that negative in front of the sign has made my graph flip over the x-axis, correct? Secondly, that 2 in front of the x inside the parenthesis has had an effect on my period. See that? Now my domain has not changed. And I have to tell you, what is my amplitude? My amplitude is equal to the absolute value of negative 1, which is still 1. So check it out. That has no effect on my range. My range is not affected because my amplitude is still positive 1. Okay? It's a reflection over the x-axis though. However, like I just said, my period has been affected. So my period, notice, is just pi. All right? I want to talk about the little formula we have for the period. Here it is. T is equal to 2 pi over omega. Remember, omega is that number in front of the x in a parenthesis, okay? All right, so I could do the same thing, an XY chart for the cosine, but I'm going to not waste your time. I'm going to have you guys try it. And here's the cosine function, okay? Let's just talk about that really quick. Domain is all real numbers. Range is still negative 1 to positive 1. Clearly now this is symmetric to the y-axis, so this is an even function. And look where it goes. It starts here, it goes to here, and then it repeats itself. So this period is also 2 pi. Okay, here are all these things here. You guys are all set to do any kind of transformations. And I will see you guys tomorrow. Bye.